When exploring an unknown environment, robots often have to traverse challenging terrains while gathering the information. Aerial robots are highly mobile but cannot carry much payload. On the other hand, ground robots can carry a lot of weight but have limited sensor coverage. We propose a tethered cooperative system to compensate for weak points of each platform. The aerial robot provides a sensor information from high altitude and the ground robot utilizes it for mapping and path planning. Furthermore, to help the ground robot climb steep hill, the aerial robot anchors the tether at the top of the cliff. Then the ground robot can climb by winding the attached tether. We use custom aerial and ground robot platforms as shown here. Here, we demonstrate an obstacle avoidance and autonomous landing. The UAV uses visual inertial odometry for localization, and also creates a voxel map from its DOF sensor, to plan a path to avoid an obstacle. We use model predictive control for position control and trajectory following. Finally, the robot finds a place for autonomous landing by analyzing the terrain. In this experiment, we tested capabilities of UGV's winch. Firstly, we checked the platform performance on the staircase. With the current configuration, the robot was able to successfully fulfill the mission. Finally, we check whether UGV is able to climb the straight wall with only a winch. The hook can either cath its own wire, attached to the protrusion in the ground surface or an obstacle. Here we confirm the success of an experiment. The robot uses data from aerial robot to map the environment and calculate the traversability of each region to plan the path. It also calculates the target position for UAV to advance and final landing point. Finally, we perform a joint experiment. Here, the aerial and ground robots start from a certain position and move towards the goal. The UAV moves ahead of the UGV to create a map. Then, the UGV follows while avoiding the obstacle. When the robots reach the cliff, the UAV starts to find a pole to anchor the tether. Once it finds the pole, the UAV flies around the pole and lands to the nearby area. Finally, the UGV winds the tether with its winch to climb the cliff.